Yeah, it better happen. All right. So let me give you guys a few things before I lose any of you out the door. Practice final and the practice test 4. I know, man. Because like just yesterday, I was going over the syllabus.
Really? Like, really? So what's this? The final. I feel like really after that, I'm scared. Oh, thanks.
Anytime.
Do you see the first one? What are you supposed to do? Maybe that's what we have on here.
That's not. No, you just need to put it this way and then you on.
Okay. Oh no.
No, it's very good.
Well, this stuff right here, the K through N, that's 8.1. We're gonna go over that today.
And we did do that.
What do you do? Make it an improper fraction first. Do you know how to do that K through N? Is that what I think you should go on erasing one of these. Yeah.
So this Wednesday is review day for the test. So I'll have the answer key for the practice test this Wednesday. I'll have the answer key for the practice final next week. And then next Monday, of course, is the what happens? The test.
Right.
And next Wednesday is review for the final.
And then the
next week is the last week of classes.
I passed back all the test ones. Can I pass them?
Oh.
I passed them all back because I thought it was like, oh, you forgot some of the final ones. Yeah. Thank you.
Okay. So any questions about the remainder of the semester? It's insane. So today, I don't know if you realize, today's the last day we're doing new stuff.
Yay! We can't stand any more new stuff.
Say again? Of course you can. Yeah.
How many chapters? How much more have we learned?
We're finishing up something in 8, and then we're going to go back and definitely do 3-6. So here's what's definitely happening. We're not doing section 8-7. That's out. So you can cross through that with permanent marker if you want to. We already did 8-1, 8-2, and 8-3. I just have a few things out of 8-2 to finish up.
You already did 8, 2, and 3?
Oh, yes. 8-3 was adding, subtracting, like termed. You know, like square root of 7 plus square root of 7 is 2 square root of 7.
Because I only have up to 8-1.
I know.
Okay.
And I know that several of you like the notes to be section-wise, but I like to show you ideas. They're all linked together, and the minute I start saying, now we're in section 8-2, now we're in section 8-3, everybody's like, oh, look at all the stuff we're doing. When it's all related, it's all like the same thing. So very often I won't tell you which section we're in because I don't want you to realize how much we're doing. They're all the same thing.
8-2?
Say again?
We're stopping at 8-2 and then going to 3?
Yeah, so we did 8-1, 8-2, 8-3 last time. There's a few things in 8-2 that I need to go back. Specific little things that I need to talk about. And the main focus today is going to be 3-6. I don't know if you guys realize, I put 3-6 way at the end because those 3-6 doesn't really come into anything, but the next math you take, 103 or 110, they're going to expect you to have seen these things. So I figure I might as well do it at the end, so hopefully it's fresh in the brain when you go to the next level. Okay. So, way back up. 8-3, we did. We'll do a couple out of 8-3 again. Any specific questions or? From 8-1, 8-2, 8-3? Any specific things?
General idea.
I know, right?
So, 8-1. Stuff like, they start with things like this. Square root of 64.
No.
8. Because when you see the square root, how many parts is it asking you to break this number into? 2. So the second root, the square root, you break it into 2 parts, just like you would do with difference of squares, right? So this number should sound very familiar. 8, because if it was x squared minus 64, it would be x minus 8, x plus 8. You've already done roots, you just didn't realize it. So square root of 64 is 8. What's the cube root of 64? 4. Because if you break 64 into 3 parts, it's 4 times 4 times 4. So that's the connection between the root and the answer. The root is asking you, if you break this into 3 parts, what are each of those parts? Or even better, what does it take this many of to multiply to be this? And of course it takes 3 4s to multiply to be 64. So the reason people don't really like roots is because they are thinking backwards. You don't actually do something to this necessarily. You got to think, what would it take 3 of to make that? What would it take 2 of to make this? Yeah?
What is the highest root that we're going to go up to? Does that make sense?
On some problems, I can go as high as I want to. And I'll show you what I mean.
Okay.
Obviously, it would be really evil of me to do like the 11th root of 4,890. I'm not going to do that. But there's a specific type of problem. Let me show you right now. What do you think the square root of x to the 4th is?
X squared? X.
Yeah, because, careful. Square root. Square root says cut it in how many parts? 2.
So it's x squared.
Square root. So it cut it in half, x squared.
Okay.
You guys with me so far?
Mm-hmm.
So what's the, yes?
So what if you get x to the 3rd square root of x?
We're getting to that. But right now I want to focus on when the root actually goes evenly with this. You're thinking about what if they don't. That's the next level. We're not quite there yet. So what about this? What about the 10th root? This is what I was talking about earlier. Whoever asked me what the highest root would be. What's the 10th root of A20? Yeah, because how many parts do you break this up into? 10. 10 goes into 20 twice. So that's why it's a squared. How are we doing? So I want you to realize it's not conceptually that big of a step from this easy problem to this what looks like a hard problem. It's the same thing. Break it into 10 parts. If I have 20 things and I break it into 10, they each have 2. And the shortcut, this kicks so much ass. I don't divide 64 by 2, obviously, right? That's not the idea. This is not a division symbol. But exponents are not numbers. I keep telling you that. And sure enough, look what we did. 10 goes into 20 twice. Because if I break this into 10 parts, it'll each be a squared. With me?
So it's the
Division of exponents. Exactly. Yes, ma'am.
What if you put like a negative on the outside and on the inside?
Well, if you have the square root of negative 16.
What if there's also a negative on
I'll get to that.
No, you said that no number can multiply itself to a negative.
I love it. So the answer here would be officially, not that yet, because we haven't talked about that, but just not a real number.
So it's not negative 4?
Now, if you thought it was negative 4, how do I check any of these, what I've done? How would I check this answer?
Multiply it.
Multiply by itself twice, right? 8 times 8 is 64. How do I check this one? 4 times 4 times 4, because it needs 3 of them, right? And that checks out. How would I check? If I thought the answer to this was negative 4,
You do 4, negative
I
4.
multiply this by itself. And what's negative 4 times negative 4? It's not negative 16, so that can't be the answer. So the only answer that kind of makes sense is not the answer. Therefore, there is no real answer. Not real or no real answer.
We're not gonna find much of that though. Are we on there, on the test?
Not much, but it will show up. You know it will. But not every one. Don't say not real, not real, not real. And then factoring prime. Not a good idea.
So when I looked on the test, it got into like numbers and
Oh yeah, we're getting there.
variables. Okay.
We're getting there. I got to build, you know me.
I know.
So, how would I do the cube root of 8a6b9? And And one of the main ideas from this whole semester has been do it in parts. When you distribute or anything, you do the numbers, then you do the variables as they come, right? When you have like 8xy times 4x squared y cubed, you do 8 times 4, and then you multiply the x's, and then multiply these. So we do it like that. So when I have this, I do it the same way. What's the cube root of 8? 2. Break A6 into 3 parts. Or you can even, the nice shortcut is 3 goes into 6 twice, 3 goes into 9. Now, like Hala said earlier, you can only divide the powers. This is not 3 goes into 8. Of course not. How are we doing so far? Because exponents, when you multiply, you add, right? So that's why when I divide, I actually, let me see. These act directly on each other. 3 goes into 6 twice, but this is not in exponent form, so I can't do that. A quick little side note. If I broke 8 up, what would it be if you factor it? 2 times 2 times 2, which is 2 cubed, right? Now 3 goes into 3 once. So it's still 2. If you put it in exponent form, you could divide the exponents. If it's not in exponential form, you don't suddenly start dividing. You can't say 3 doesn't go with 8, Jeff. So no. You have to do it cube root of 8. You have to think differently because it's not an exponent. You have to treat it differently. Okay.
So is that the answer for the .com?
Yeah, this is it. Cool. Right here. This was me just showing you a little specific. Cool. How are we doing so far?
And that's just A1. That's most of this. That's all we're doing A1.
A1 is based on this idea. So, to answer somebody else's question, what do you do if you have, well, let me start off not too evil. Square root of x cubed.
You break it into 2.
And believe it or not, we've done this, exactly. Somebody recall, how do you do the square root of 50? How do you simplify that? If you weren't here last time, you might not have a clue, but let me see if you were here before, do you remember?
You factored it out to like 25 and 2.
Yeah, you break it into parts, a part that you can do and a part that you can't do. So you break it into 25 times 2. Why don't you break it into 5 times 10? Can you do the square root of 5 or the square root of 10? No, so don't break it up like that. Break it up into a part you can do times whatever the hell makes it work, right? So 25 times 2 is 50. The square root of 25 is 5. The square root of 2 is, I don't know. Maybe. So it's sort of like, and I showed you last time the analogy. Remember that 10 over 7 I had before? We can make it into a mixed number by doing this. I break it up into a part that I can divide by 7 and a part that I can't divide by 7. I do the part that I can, and I don't do the part that I can't. It's the same idea. 10 has a 7 in it. Divided by 7 will be a whole one. And then it's got these 3 extra pieces. Damn, so that's 3/7 of something. It's not a whole thing. You guys with me? Well, that's the whole idea of fractions. If it was 14, it'd be 2. If it was 7, it'd be 1. But it's in the middle. So it's 1 and some part of it, right? So here, it's kind of like the same idea. Square root of 50 is got a part in it that works and a part in it that doesn't. It's the same idea. So to kind of reduce it, they call it simplifying a radical, but since it's so much like this, I call it kind of like reducing my square root, or I can't remember what I call it now. But square root of 25 is 5, and the square root of 2 just stays there. Just like the 3 just stays on top of the 7. The 2 just stays inside the square root because it can't do it.
So
Talking that thing to death, but I want you to understand this.
So square of minus 16 would be like 4 times square of minus 1?
Yes. So if we were talking about imaginary numbers, we could do the next step. That's going to be in the next level.
No, you say here. You say
But we're not talking about, yeah. I mean, if I had the square root of negative 4,
negative.
the square root of 4 times square root of negative 1.
Yeah.
This is the part that would lead to imaginary numbers, and we're not talking about that. That'll be in 103 or 110, whichever one you take next. Which is the same idea.
Okay, so what's the square root of x
So now let's come back to this. Why can't I, what number should be there for me to be able to do that?
4.
A 2 or a 4, right? So one way to look at this is, there's an x squared in there, isn't there? There's just an extra x in there with it. So the long way to do this is to break it up. Just like I broke this number up, I could break up the radical. What's the square root of x squared? And we'll talk about that a little more in depth, but right now we'll say it's x. And what's the square root of x? I don't know. And you should, I mean, this is overloaded with x's, right? X squared I could do, this has got x cubed. So it's sort of like 10 over 7. The top is bigger than the bottom, so it should be able to be done. The power is bigger than the root. It should be able to be done. Something should be able to reduce in it. I should be able to rewrite it. Okay, maybe. So, for example, let's do a higher power.
So you couldn't do like x to the 1.5?
Yes, actually, yes. You're
Yeah,
right.
that
And
would
that's
work?
that's because I told you last time that square roots are like a half power.
Yeah.
That's exactly
So if
what
I
would
just
work.
said equals x to the 1.5, would I get it right?
Not quite.
Oh.
Write them as fractional powers. But even then, no. I want to see this.
Okay.
Yeah. So what about this here? Cube root of, let's just do a number first. Cube root of 16. How would you break that up? Can you do the cube root of 16? No, there's no number that I can multiply by itself 3 times and make 16. I can multiply 2 4 times and make, oh damn. But think about what we just said. How many 2's are in 16? No, let me try again. 4 of them, right? 2 times 2 times 2 times 2. This is all about multiplication here, right? Not about addition. So there are 4 2's in there. So there are definitely at least 3 of them in there, right? 3 2's in there. What number can I take the cube root of? What's the smallest number that would work in a difference of cubes? X cubed minus 8. Now 1 of course would work. That's kind of like, whoop-de-doo 1. So I can break this up as the cube root of 8 times the cube root, and this is maybe what you guys were thinking about earlier. 8 times what? 2. So if that's what you were thinking about earlier, that's fine. Why would I do this? Because what's the cube root of 8? So I break it up so I can do a part of it, and then the other part I just leave. It's exactly, and you had a good point. It's so much like doing a mixed number that the powers themselves are mixed numbers. That's why I use that as a nice analogy. Same idea. So the cube root of 8 is 2. What's the cube root of 2? I have no freaking idea. So I break it up into a part that I can do, times the part that I can't do. I do the part I can, I leave the part I can't. Okay. Maybe. Yes.
So you chose the 8 and the 2 because 8 times 2 is 16.
And because 8 can have the cube root done. So I could do 4
Okay.
times 4, but that's silly because I can't do the cube root of 4.
Okay.
So you want to break it up smart. You want to break it up into a part you can do and then times whatever else.
Okay.
Right? So what about cube root of 207? So think about the numbers that you can do the cube root of. 8. What else would work in a difference of cubes or sum of cubes? 64, not 9. 9 is only 2 3's. What's 3 3's? 27. There you go. So you would break this up as 27 times 10.
Oh, first one.
Let me not do that. I don't need this.
Okay, so first break it apart.
But do it smart. Think about what number can do the cube root of. So 27 I can do the cube root of. Right? In fact, I think part of this homework is 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and you got to make that list.
Yeah.
Because if you know your cubes, or if you just keep a list sitting next to you, you know what numbers to look for.
Find that anywhere.
You make it.
Can we bring it to the class?
Right?
You can, and then you leave it in your bag.
Oh.
Aw, Jeff, that was mean.
Oh, that was mean, Jeff.
Oh well, I get over it. I'm over it. So what's the cube root of 27? 3. And what's the cube root of 10?
We don't know.
I have no freaking clue, so yeah.
Okay, so if there isn't a square root, then if you put it.
Or a root, whatever root, you just leave it there.
I just don't understand how you said it. Since the square root of 27 is 3, you put it on the side like that.
Cube root of 27 is 3.
So you put it.
What are these two things doing?
Multiply.
So whatever this is, it's multiplying by what this is. That's what it says, right? So since the cube root of 27 is 3, it's multiplying by the cube root of 10.
Got it.
Just because I simplify a part of a problem, I can't change the operation. And we've made that mistake before. We've had where I put subtraction can't become multiplication. You all have seen that kind of note from me. So this is multiplication. It better still be freaking multiplication. Just because I say that's 3 and I can't change it to something else. So you just have it sitting there in front of this guy.
I just don't understand.
What's up?
I'm not explaining it. I'll figure it out.
All right. So let's try this here. Let me show you a shortcut for this kind of thing here. How many extra x's are in there?
2.
So it should make sense. And how do you know that?
Yeah, how do you know that?
5 minutes.
Well, what number should be in there? 5 can go into 5.
Yeah.
And then there's 2 more than that, isn't there?
I see that.
Cool. And actually, a more direct way to think about it is 5 goes into 7 once with how many left?
2.
With 2 left inside. You got to love it. The way you've said it since you first learned long division is the way you do these. We know now that roots divide into powers, right? We just said that earlier. We all cool with that?
So you brought out the x to the 5.
Careful, I didn't bring it out. The 5th root of the 5 x's is 1. And then there's 2 left over. So the long way to do that problem, I really want you guys to get this because this shortcut kicks so much ass. The long way to do that problem is to actually rewrite it. Is it cool if I do that? Isn't that the same thing? What's x to the 7? X to the 5th times x squared, right? They gotta both have a 5th root on it.
Added them together. Or that's.
Thank you, I do too, but I just want to.
See? What you said?
No, I was telling him I like the other way better, but when I needed help last week, you couldn't hear me. When I'm talking in the church, you can't hear.
Well, speak up. Don't hope I hear you.
He only hears you when you don't want him to.
So, are you guys cool with this so far?
Kind of.
This is exactly what we did with the numbers, isn't it? We broke it up into a part that I could do and a part that I can't. So, of course, 5 goes into 5 evenly. So, what's 5th root of x5?
5 is the square root.
X. You with me? 5 goes into 5 once. And, of course, these are still in there because 5 doesn't go into 2. But the shortcut kicks so much ass because you should be able to handle remainders.
Yeah.
If you can't, you shouldn't actually be in this class, right? 5 goes into 7 once with 2 remaining. So you write it exactly the way you say it. This is why the shortcut works, because we would write the excess off to the side. That's the remaining piece. So what about this here? I like it. Of course, had to pick an A and a 9. That's a good job, Jeff. But I said
Yeah.
A to the 9th, okay?
Right, not A to the
Not a
8.
9 to the 8th. A. Yeah. So here's the shortcut. This is so awesome. 4 goes into 9.
Twice.
So what do I write? A squared, right? 4 goes into 9 twice. So I can have A squared come out for the A8. With 1 left over. 4 goes into 15. 3. With 4 goes into 15. 3 times with 3 left over. Again, just to make sure we're all on the same page. If I did it the other way. So that's the answer right there.
Wait, so you have that because A squared e to the 3rd with the 4 and the little thingy.
Yes.
And then A.
It's a radical.
A radical.
Good.
Okay, and then A to the
So to show you the other way, if you like the other way better, it's fine. 9 kind of sucks. What's the next number below it that 4 goes into? 8. So I want to write this as A8 times that stupid extra A. Right? That's, and again, if you don't like this way, don't do it.
I like it.
Do this way. Right? If you don't like this way, hopefully I like this one, or else we got to come up with someone else who may come and see me. 4 doesn't go into 15. What's the next number down that it goes into? 12. And how many extra B's are there then to make 15? 3. So which piece of this can I do? I can do this piece. What's the 4 through 8? 8. 4 goes into 8 twice. 4 goes into 12.
3.
And what's still in there that I can't do? The A and the B cubes. It's the same answer. Of course it's the same answer. That extra that we have to take out of the way, that's the remainder. That's the remaining piece.
Okay.
Yeah, let me do another.
Okay.
I still have people looking at me like I'm crazy.
How do you get a remainder of 2 out of 9 and 8?
4 goes into 9
8.
twice with 1 left over. See, there's 1 A left over, right?
Where's the A2 over here?
4 goes into 9 twice
No.
with 1 left inside.
So all the
4 goes into 15 3 times with 3 left inside.
This one, like, 4 times 2 is
How we doing?
8. Makes it better at 2 times, so there's 1 over here. And then 4 times 3 is 12.
So you got 2 main ways to do it. They're actually the same. But if you like this way better because it looks a little more like you can actually do these and then you can see that these are there, so they're still there. I understand. This is more in the head, but you should be able to handle division with remainders. So what about this here?
Oh, that's.
I like it.
What do you like? 45.
So does 5 go into 2?
No.
So that whole thing is left inside. Is that cool?
That's gonna be inside.
How many A's would I need inside of a 5th root to be able to do it?
At least
5 of them. I've only got 2. So that makes sense. I can't do shit with that. There's not enough.
So you just leave alone.
Yeah, that's all I can do. Right? It's sort of like write that as a mixed number. That's kind of a silly question, isn't it? Can you write that as a mixed number? Not really, because is there a whole piece of it? Is that even over 1? No, it's less than 1. I can't write that as a mixed number. You guys with me? If I had 7/5, why do I know I can write that as a mixed number? Because it's bigger than 1. Or the 7 is bigger than 5. The whole thing is bigger than 1. So there's only 2 A's. I know I can't do anything with them because I have to have at least 5 to do anything. Cool. So 5th roots are looking for 5 things, right?
Okay.
Why can it do the square root of 49? Because square root is looking for 2 things and 49 has 2 7s. So I can't do this because it's only got 2 and it's looking for 5 of them. Good.
Okay.
So 5 goes into 2? Nope. 5 goes into 12 twice with 2 left over. And see how I'm leaving room, right? You see how I'm leaving room, so I have room to put stuff. 5 goes into 44.
9.
Not quite 9.
8 to 8.
8 times
And then there's
with
4 left over.
4 left.
You can do that way. Cool beans.
So I really hope that the reason that shortcut works, that you understand the reason it works. Even if you don't, can you do the shortcut? That's the bare minimum, I believe. If you understand why it works a little bit, I'm like, yes. Yeah.
Okay, so if the coefficient is already with the variable and the exponent, we just divide that as well with it all. It can be divided.
If there's a number inside, you mean?
Yeah.
All right, that's the next thing to do. So if there's a number inside, stay with me now. Alright, so this is the hardest problem to do. And it's actually not because it's itself is difficult, it's because it's got 2 kind of separate things I gotta do. I get some numbers with exponents, and some things that are actually really numbers, right? I have these variables with exponents, so that's easy. But how do I do the cube root of 54? Who remembers how to do that kind of thing? Can I take the cube root of 54?
Is it 14?
14 times 14 times 14 is not 54. Is there any number I multiply 3 times to make 54? No. Hell no. Right? Because it goes from 8 to 27. You guys with me? 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. Oh shit, there's nothing in the middle. 27 times 2. So you break that up into 27 times 2. So you have to, and I'm hoping this is sunk in, because this is the biggest complaint besides, what do we do in math? This is the biggest complaint about math that I hear is, things change. Things suddenly change. No, these are powers. They act differently than numbers do. Why? Because they're not the same thing. It's that simple. So don't say, I divide there and I don't there. This is just not written in the same form. Of course it's not going to work the same way. Yeah?
What if the number was able to, you can get like a cube, a perfect cube out of it?
Well, that's what we did.
Well, what if you didn't have to break it down like that? You just go ahead
if that was
and
a 27, I would just do cube root of 27 is 3 and write that outside.
Okay.
Yeah. So nothing comes out. It's that I do the root so I can write it as a whole number. So be careful about saying that you brought it out. You're not really bringing it out. You're doing the root. So that's why I can write it outside now. So what's the cube root of 27? 3. And what's the cube root of 2?
2.
I don't know.
So the 2 stays inside.
2 stays. 3 goes into 11. 3 times with 2 left over, right? Is that cool? 3 goes into 9. 3 times there's an excess of 2 in there. 3 goes into 21. 7 times with nothing left over, 11. So I had a little bit of everything in there. There was a number that I could break down. There was something that had parts left, and there was something that went in perfectly. Right? So all 3 of those can happen. They're not really different. Do you see 3 goes into 21 7 times with none left over? It's not different.
You don't have to put
I just don't have to write B's there.
Okay.
They all were able to be done. Okay, this is cool. Hopefully.
Wait, I got confused with the 8 11. How did you break it up?
3 goes into 11 3 times with 2 left over. Because there's an extra 2 A's in there. Because if it was 9, 3 can go into 9 perfectly. There's no excess B's. There's no extra B's because 3 goes into 21. That's why there were none left. But there are 2 extra A's, so guess what? There they are. I can see them now.
Yeah.
Cool.
Okay. I'm a little worried I'll forget about the cube. Like, you brought the 27 out of 54 because it was cube, right? So I just
Cool. So you just got to think about what numbers could the cube root handle and look for those. Or you can just start dividing this number by 2, by 3, and then see if you see a number that sounds familiar. If you took 54 divided by 2 and you get 27, you should go, oh yeah, 27 will work.
3, so,
Yeah.
Okay. And then whatever that answer is, like, let's say another problem, you bring that number out to this side, like on the other side.
You write that number out. Exactly. Okay. Let me let you guys try one of these on your own.
that a
It's
1?
understood to be what? It's not 1.
A 2.
2. The first root wouldn't make any sense. What does it take 1 of to make 8? 8. So there's no such thing as a first root. The reason we don't write the 2 here is because the square root is the most commonly used. So we said screw the 2 because math people, we're lazy. So like if we don't write that 2, we save a bunch of time over our lifetime. So screw it.
Yeah. Oh, yeah.
So that's why the square root is an understood 2 there.
Okay.
Okay. So we know that means square root, second root.
Okay.
So how do I break 75 up?
25.
Oh, yeah.
Good.
Wait, okay, I didn't do it that way.
Right.
25 can be squared.
Exactly. That's why we did it that way, right? We could do it as 15 times 5, but I can't do square root of 15 over 5, right? How did you do it?
Well, I thought if I did 8 and 8, that's 64, and then I could do the remainder. So I took an 8 out, and then I didn't know what to do.
Oh,
so I just went to the.
It's got to be based on multiplication. There's no remainder. I'm not dividing 75 by 8. So if you say 75 is 8 times 8 plus, nope, you can't.
Okay.
You can't say there's plus something yet.
Okay.
The reason, and see, that's all part of the. Why do you treat these differently than these, Jeff? Why does math do that to me?
Yeah.
These are W, right? There's 5 W's in a row. It's all multiplication. There's no addition there.
Yeah.
So that's why I can treat them a little more directly. This is not written in that format, so I've got to do it in a little bit different way. So be careful about, that kind of thinking is what leads us to doing something like this. 14 divided by 10, and we say it's 4. Why do you think somebody would say that?
There's 4 left over.
Because they got used to subtracting exponents, so they thought the numbers did the same thing, and of course numbers do not act the same as exponents. Because they're 2 different things. So you break that up, and then these guys you can leave alone. Square root of 25 is
5.
5. Square root of 3, I don't know, so it just stays in there. Square root 2 goes into 5. 2 times with 1. Does 2 go into 1 for the z? So the z is just stuck in there. How we doing? 2 goes into 11. 5 times with 1 left over. 11. So what's the only letter that didn't escape, that didn't have somebody escape? Z, because they only had 1 and the square root requires 2 to even look at trying to do something. With me? Okay, maybe. Very often what people will do after this, for some reason, what I see a lot of is on the next step here I see 3 and I see a 25 still in there. Now how did 3 get out of there? The square root of 3 is not equal to 3. So this step is you're actually doing, you're not taking something out. The square root of 25 is 5. Cool? And this whole 2 goes into 5 thing, that is a shortcut. We are doing the square root of W4 is W squared, and we add an extra W in there. That's what we're really doing. But the shortcut is so awesome. Just divide the things and say it out loud, remainder blah. Put that many in there. That's how many remain. Remainder blah. Okay. Let's see. All right, so that was the last piece of section 8.2 that I needed to do. And just a real quick review of 8.3 before we get into 3.6. 8.3 was the first place and the only place for us that we'll see an application of what we just did. So where can you actually apply this? It would be a problem like this. So first step is, are those like terms? Can I actually do that subtraction? Here I got 2 square root of 75s minus 3 square root of 12s. There's no damn way I can put those together. Right? If it was 2 square root of 5 minus 3 square root of 5, I could do that. So what should I try to do with each of those? Break them down. Try to reduce them. Right? So it's sort of like, it's a lot like when I have fractions and I'm trying to do something with them. I could try to build this one up, or even if I had, let me see, if I had, You can think about it, Jay. If I had this, the smart thing to do on that problem would be to reduce this, right? Then they'd have like denominators. So here I'm kind of like, how can I reduce this? How can I simplify this and hope that what's left is actually like terms with the other one? Yes, ma'am.
So the remainders are the, like, kind of like the denominators?
In a way, exactly.
Okay.
Exactly. So here I've got 2 times what? We just did that one, so.
25.
Minus 3, how do I break 12 up? What can I do the square root of that's a part of 12? 4. So it'd be square root of 4, square root of 3. And you guys see what's going to be left over at the end? Some square roots of 3's, and I can put those together then.
You
So-
put them together, or do they cancel out?
We'll see.
Okay.
2 times square root of 25, so 2 times
That's
5 minus 3 times 2, because that's square root of 4. So what number is here now? 10. Everybody gets confused about what to do with that number. It's multiplying, so whatever you actually have written outside just multiplies with it. So I had a square root of 25, that's 5. So 5 times 2 that's already out there is 10. And here I had a square root of 4 is 2, so 2 times the 3 that's already out there. So what's 10 of these minus 6 of these? 4 of these. Just like 10x minus 6x is 4x. Okay. All right, we'll do another one.
Oh, yeah.
You guys didn't say anything. Tell me slow down, it's not a big deal. All right, let's see. Let's see. That'll work. What is that?
Sorry, the last one, where did you found 4? Sorry.
So if I have 10 of these minus 6 of these, 4 of these. So this is exactly like 10x minus 6x is 4x. Same exact thing. Why does it make sense? What is the square root of 3? I don't know. What's x? I don't know. So I got 10 of something I don't know minus 6 of the same damn thing is 4 of those things that I don't know. 10 of these things I don't know minus 6 of these things I don't know is 4 of these damn things I don't know. It's just collecting stuff. Why can I put them together? Because it's the same stuff.
It's kind of like a like term, maybe?
It is a like term. They are like terms. I love it. Okay. So up here, are these currently like terms?
No.
The only good thing is they're both cube roots, but they're not like terms because they're not the same on the inside, right? So what can you try to do?
I break them up.
Break them up. So what number is in 24 that you can do the cube root of? 8. I love it. 8 I can do the cube root of, right? So I rewrite this as cube root of 8, cube root of 3, because that makes 24. Cool. So there's 24 right there. 8 times 3. We haven't changed anything. We just rewrote it. Right? In fact, that's mostly what we do in here. We just rewrite and rewrite and rewrite into a better form. So plus 5. How do I break up 81? Good. So break up 81 as 27 times 3. I just got a 3 kick today. I don't know why. So that's going to be left over at the end. So what is the cube root of 8? 2 times 3. I've got to write that out. So this is 3 times cube root of 8 is 2. And what's the cube root of 3? I don't know. 5 times the cube root of 27 is 3. What's the cube root of 3? I still don't know. Don't lose your little cube, dude. Don't make him suddenly become a square. Don't lose that little number. So here I get 6 cube roots of 3 plus 15 cube roots of 3 is 21 cube roots of 3. Just like terms at that stage. So we simplified the radical. We broke it up into a part we can do and a part we can't. And we ended up with q root of 8 is 2 times the 3 that was out there already is 6 cube root of 3. And thank God the other one came up to be something cube root of 3 because now they are like terms. I can actually combine them.
And if they aren't like terms, you would just keep
If you
it
aren't,
as the
if there
answer.
aren't, if that would have been like a 4 in there,
Just keep it that
you
way.
stop there. Sure, then it's like 6x plus 15y.
Okay.
6 of these things plus 15 of those other things. Not like terms then. Yeah.
So the 8 became a 2 because that's the cube of 2.
8 didn't become a 2. Cube root of 8 is 2. Cool. So I just replaced this with what it is. Why write cube root of 8 when I know it's 2? It's much better to write 2. Cool. Okay. Very excited. Like, yes. Yeah.
Okay, so let's just do like real quick run through. First, you break them up, and then you make the like terms, and then you keep those like terms throughout the whole problem, and only.
Now
take
I want to
the
be careful.
first part.
You're not making these like terms. You're kind of hoping that they'll become like terms. And we're lucky so far, and of course most of the ones we're going to work with will. But like was pointed out here, in real life, there's nothing that says these have to be the same at the end. And there's no way to force them to be the same. The only reason these were the same is because they both had an extra 3 factor in them. And of course I made it that way.
But if they don't have something that's.
Then you just
can't
can't combine it.
Yeah.
Then you just let go of it. Yeah. So if I had like 5 cube root of 3 plus 4 cube root of 4, I stop right there. I can't do anything with that. 5 of these plus 4 of those. I can't. It's like 5x plus 4y. Because x and y are not the same. Not like terms. I can't consolidate. And they can't become 9 what? I don't have 9 of anything. I have 5 of these and 4 of those. I don't have 9 anythings. Cool. Here, I got 21 somethings. Because I got 6 of these and 15 of these. That's 21 of those. That's why I can put those together. Okay, so let's do this. Let's take a break. And then we're going to get into section 3.6. Functions. So let's take a break, come back at 4:40. What's that?
The easiest way to like, because what's hard for me is like breaking it down into like 8 and 3 or